Today we're going to talk about MIGs. All the different kind of uses. There's going to be multiple parts to these episodes for each different kinds of welders or cutters. This is a MIG welder. Generally there's two different kinds of MIG welders. There's actual MIG welder, which stands for metal inert gas, and there's also a flux core welder, which does not use gas. You can use a MIG to flux core, but you can't use a flux core to MIG. What it is this has provisions for gas to be delivered out the hose when you pull the trigger. Flux core, all the stuff that shields it is actually in the wire, so you need to use a lot more wire as you weld. It's also a lot of slag and stuff on it, so it doesn't come out looking as nice. You have to watch out for these because there is a lot of splat. I'm D, and this is D-Mon's Garage.
And when would I use
this? Is generally what you'll use for most of your stuff. Technically, you use these for aluminum. They don't work really well for aluminum. You have to buy a spool gun. The majority of your welds, even spot welds and stuff, you'll use this.
Can I cut with it?
No. You can stick two pieces of metal together in varying levels of degrees. Most stainless steel, you can stick two pieces of metal together.
Depending. It's expensive to run it?
Not really. There are different kinds. You have 110 and you have 220. You have to have 220 in your shop or wherever you're welding, but you can weld thicker material with it. The gas and the consumables are the two biggest things, so wire and gas.
Are there different wires that I would use for different things?
Yes. It depends on your base metal and your actual machine and how thick of the metal you're welding.
So it comes with a book that would tell me this?
Yes. A lot of them actually, it's on the side panel. There's a couple of things, common sense stuff, like if you're welding stainless steel, you don't use mild steel wire. And then if you're welding stainless steel, you use tri-gas instead of mixed gas.
I will use whatever you tell me to use. Nifty chart.
So in most cases, most of the welders either come with a chart on the machine or it'll come with a book. I prefer them on the machine. This isn't always necessarily right depending on how you weld, but it'll get you into the ballpark. So what it is, there's a spool of wire. There's different sizes. You can get a pound, you can get 5 pound, you can get really big spools. And what it is, as you hit the button, it feeds this wire through.
Does it have a maximum size that you can fit inside there and close the door?
Depends on the machine, but yeah, usually.
Watch that.
Yeah, usually the 5 pound spools are fairly large. This, like I said, this is a 1 pound spool, I believe. This will do for a while. The big spools, if you're welding a lot of wire, this way you don't have to change them. So what happens is when you hit the button, it releases a gas because it's MIG, and it shields where you're welding, and it pushes this wire out. Well, this wire is electrified. And then what you're doing is you're actually heating this metal and the base metal and then kind of melting them together.
Are there any parts on these that tend to go bad that we should think about buying extra when we get it, just so we've got on hand?
Generally, the worst thing is the tips. Is actually where the wire comes out of. These tips come in different sizes depending on the size of your wire. Because if you use a really big tip and you're using a really small wire, it's gonna kind of wherever it feels like going instead of pushing straight out into a line. And then you can always get a couple extra gas shields. These are metal, they don't generally go bad. Occasionally they'll just get nasty.
And all these things I could get at a welding shop?
Yep.
Is there any place else that would be a good place to look for them besides the machine, maybe on like eBay or Facebook?
Amazon. A lot of the consumables are universal. Some of them aren't. Some of them are weird Chinese sizes and it becomes an issue to get parts for them. The actual consumables.
So if I went and got, say, a machine that was not a name brand here, would I be able to still use the wire and the gas from here?
Yes, you could use the wire and the gas.
But the tips might not work.
But the tips might not work.
Is there anything else about this machine that you would want to know if you were buying it for the first time? Or
if you're buying a used one, make sure that like I said, you want it to have gas. You can use flux core. But I personally don't like the way the welds come out. There's a lot more cleaning afterwards, but you don't need gas. But make sure if you're buying it used, it comes with a pressure regulator. If you can get it with the tank, it's beneficial because these tanks are actually, the initial buyout on these tanks is kind of expensive. This is a small tank. They make very large tanks.
Like the ones for your cutting torches? Yeah,
those are actually like a medium-sized tank, but they make huge bottles. Depending on how much you're welding has to do with, because when you run out of gas, you have to stop welding because that gas actually shields it, and you'll end up with inclusions and porosity, and it won't weld correctly because of air getting into where the weld is.
So this would be a great first welder, though.
Yeah, this is generally a really good welder.
Before cutting torches, even?
It all depends on what you're doing. This will stick two pieces of metal together. With a set of cutting torches, as long as you have the tip, technically you can stick two pieces of metal together, but it's a lot harder.
Now, with the cutting torches, I can use a coat hanger, but with this, I can half full of wire.
Well, you could use, if you have a big gap, you can actually, you clean up the coat hanger, or you can even take a piece of welding wire, steel welding wire, and you can stick it in that gap, and then you can walk it across, and it'll kind of to gap out, or bridge out the gap. So there's a couple of different ways, motions that you can use when you weld. You always want to be pushing your weld, because if you draw your weld, you're not pushing the material into your weld.
Is it also more likely to spark towards you if you draw it towards yourself and be more dangerous?
No, not really. But what it is, you end up depositing the metal on top of, instead of, as you're heating, you're now pushing the wire into the weld.
Okay, I think I understand that. One goes on top and one goes in between.
Yeah, so
like
you don't get as much penetration, is the whole theory. Get your mind out of the gutter, young lady.
Don't let your kid edit this piece.
Okay, so one of the ways is what they call a C. And basically what you do is you just sit there and you keep walking back and forth across, your line.
Is that how we get that pretty quarter look you showed me?
No. And actually, depending on a MIG, you really kind of don't want the corner. You kind of want this to actually be built up a little bit. You want a little bit of a mound. You don't want a big round thing, because then you're not actually heating the metal enough. You will end up with, you really only get what they call stacking dimes when you're TIG welding, and it's more because of the way you TIG weld. There's people that can do it with oxy and acetylene, but like I said, because once upon a time, that's actually how all welding was done. And before that, you used to do what's known as rivet, kind of like a nail. And what they do is they get it cherry red, shove it through the hole, and then hammer on both sides, and it would squash out the ends. That was before welding was a big thing, or it was a lot harder. So you can do a C, right? The next one would be what they call, it's a script S basically, and you start out and you go, which is pretty much the same thing. The other thing is what they call, and then you go like this over your weld.
Loop-de-loop.
Yeah, pretty much.
Now, I see that you've got different sizes there. How do you know how wide to go on each side of it?
Truthfully, the correct answer is the thickness of the material. You want to have a little more than whatever the thickness of the material is onto each side. If you get really thick material, what you actually want to do is where they come together, you want to V them down. So this way, as you weld, and then you actually weld more in the V. And you want to have, about a 45-degree angle without making the very bottom really sharp, because where it's sharp, it'll be really thin. But you want to go about halfway through that material and carry a 45, and then you can weld. And it depends on...
Like if you're going through tech inspection, are they going to look at and go, oh, your welds are too wide, your welds aren't wide enough?
Depends on the tech inspector. I did a car, and we went up, and the tech inspector had nothing but problems with the whole cage. And I told him, look, I've welded cages on stock cars at local track for years. These welds are more acceptable. They're probably stronger than anything, because these cars are getting smashed into on a regular basis. Well, I don't like it. So eventually I got him to admit that his whole problem was the fact that he didn't like bolt-in cages. Our cages were bolted in on the floor and not welded into the rocker panels. And that was his whole problem. But it took forever to get him to admit that that was actually his problem with it. And
I was just curious about the whole inspection thing. I can't think of any other time your welds get inspected like that.
Certifications and stuff, and that's only if you're a structural welder, or if you're doing that for a living, yeah. And it varies on where you go to, is how much they scrutinize it and everything else. Okay, so the last one, right? If you have your weld, it's what's known as a whip and pause. So what you do is you start building up a little bit of heat, you come up, whip back, deposit more material, come up, whip back, deposit a little more material, and just keep doing that.
Is that weaker?
What's that?
Is that weaker than the other welds?
Not really, because you're still depositing as much material, but it's just a different way. What it is
well, you're not going off on the sides to kind of pull the extra.
Yeah, but you're concentrating a lot of heat in a very small area and depositing a lot of material there, and then coming up and immediately. And what it does is this actually, as you do this, you're actually kind of preheating this metal, is the theory. And then when you come back, you deposit your material. And you keep doing that.
I thought that might be better for tin than for like the...
Okay, so on tins and stuff, or really thin metals, generally you don't do any of this. What you will do is say you have, right, say that's your two panels. Either you're butt welding them together or you're overlapping them. And if you overlap them, there's actually another technique for doing it. What you do is you heat this spot, and all you do is you put it right there, hold the trigger for half a second, just enough to get enough heat, and it'll leave it deposit. Then come down here, do this, do this, do this.
It's for spot welding.
Yeah. Well, it's tacking. And then, because what you're trying not to do, especially on tin, because as you heat it, you're putting in heat, so it'll push and then shrink. Well, if you just sit there and try to weld this, you'll put so much heat in it, it'll start distorting. So you let it cool down, and then you come back and you do a spot here, and then do a spot here, and do a spot here, and then do a spot here, and then come back and just keep doing that through the whole panel.
And you want to do that from the inside so it doesn't show?
Nope, because you'll turn around, you'll grind off your welds.
Okay, I didn't know.
You'll grind off the high spots, yeah. But you want to put just a little bit of heat, just enough to get everything hot, and deposit a little material. It should be, you should have a little bit of head sticking up, and you keep doing that.
What's the other technique if you're overlapping?
Okay, if you're doing what's known as a step weld, right? So your other piece, say this piece here, comes and hangs underneath this. So what you do is actually, generally you fold that metal, and there's a tool for doing it. I'll show it to you in a second. And then you'll turn around and you'll put a bunch of holes in it. Most cars, all the welds are put together with what's known as a pinch weld. So all it is, it's two arms that come together, press that metal together, and then it runs electricity through it at a very high current, which causes them to fuse together. And believe me, you'll start to hate pinch welds, or pinch welds, because at some point you're going to have to drill out or cut out a whole bunch of them, or figure out where they are once you start playing with cars and you start replacing metal and fixing stuff. And then all you do is you start in the center, and you get it hot, and then just go like this. And then move up to the next one. Get it hot, and then walk it around. Take it up, get it hot, walk it around. Get it hot, walking around. And what that'll do is it'll simulate the same thing. Granted, those are your only hot spots, or your only bonding spots. So you need to watch out for that. But
I would do that on the top as well, and then sand off the high spots?
Yep. You turn around, you could go through and you just hit these high spots, and you take a little bit of mud, because you'll always have, because of the fact that it's dropped down, you usually have a little bit of a gap, and then just mud this.
And by mud, you mean Bondo?
Yeah, Bondo.
I'm just
body
making
filler.
Sure that there's no...
Yep. So like I said, this is for doing steps and overlaps. It's pneumatic, so it's an air tool. And you basically put the metal in there, and then you pull the handle, and the little lever comes up, and it puts a little dimple in it.
Okay, can you click that again so we can see it move?
Well, it ain't going to move.
Oh, it's not without the air tool?
Not without the air tool.
Okay.
So this side will put a little step in it, and then this side, and it all goes at the same time, it'll poke a little hole in the steel. So what you do is you take your panel, and you hold this to it and go like this a bunch of times, and then it will put a step in, and you put your two panel, you take your other panel, you blow a couple of holes in it, and like I said, hang one over the other and just start welding. What they used to do back in the day, and I don't suggest anyone do this because lead is dangerous, is what they used to do before body filler was an actual thing, you used to do what's known as leading. And
so they might find this on an old car.
Yeah, it's very common. If it's a really old car, which is where the phrase lead sled comes from, is literally, instead of because you couldn't get plastic body filler, they used to actually take lead and then heat it up and force it in with a piece of wood, which there's special tools for. Yeah, it's a really old technique. There are some guys that still do it, but like I said, you're dealing with lead at that point. You know, when you heat that lead, it's giving off gases and everything else.
Dangerous.
Yeah.
Do they still do that anywhere, the lead sledding?
Not really. There are guys that still do it, you know.
But there's no shops that would still do that, or
Not really.
applications, maybe on trucks or something?
No, not really. Like I said, it's really gone out of favor. It's another one of those lost, dying arts. It's kind of like pinstriping. Yeah, there's guys that do it, but it's becoming fewer and fewer each year because it is very much an art form.
It is. Well, I mean, you were saying lead sledding, and I was thinking that was popular in the 50s, and I didn't know how late it went before they came out with this stuff.
50s, even into the 70s and stuff, guys are still doing it. There's guys, Wakefield. There's a couple of really popular, you know, really famous guys from the 50s that are still alive that still do this.
Well, I'm sure if that's what they...
So what they use is a tool like this. And what you do is you turn around, you get the material hot, start heating your lead on it, and then take something like this, which is just a wood handle, and kind of smooth it out and work it, and then they'd sit there and they'd file it smooth.
Did you actually do this, or is this just a tool you happen to collect?
It's one of the tools that I've happened to have. I've done a little bit of leading. I don't like doing leading. It's lead. It's heavy. It's, you know, it's dangerous. There's...
Well, you're not going to want to do it on a race car if it's heavy.
Yeah, well, yeah, kind of, depending on where you do it, but yeah. Now, why don't you get out in the garage and do something?